Hey, welcome to part two. I totally got cut off in part one. You wouldn't believe it, but I kept rambling on. The video cuts me off in 15 minutes. So, hey, here we are, part two, continuing with where we left off on the coolant control valve and the warm-up process for Gen 2 Prius. So, we left off talking about how the engine warms up on this mode, and it kind of, after we've already got the preheat, we've heated the head, and now we're up to operating temperature, or we're almost there. The engine's warming up, getting up to operating temperature, it's heating up on its own. And now, once we get to operating temperature, the ice is going to then have that sufficient hot coolant. The water valve is going to move position yet again, and it's going to replenish. See, it was going to the heater core before, but as it moves, it's going to replenish that storage tank. Notice it goes back in that spout that it came out, and it pushes the cold coolant out and refilling it with this hot coolant. And then it goes back this way, all the way back through to the water pump to the cylinder head. So it kind of repeats that little loop right there. So now once this storage tank is sufficiently filled with operating temperature coolant, it basically just kind of reroutes itself back to normal. So if the ice is shut off before the tank is filled, an electric pump is turned on to finish the filling tank. So we have hot coolant, but the tank isn't all the way filled up. You turn the car off, it's going to want to keep continuing to run that electric water pump to refill that tank. So it's ready to go for the next cold start. Okay. Anyway, 2010 and newer, again, they have that system to where they got rid of the storage tank. They use this recirculation heating unit where it actually goes down into the exhaust gas, kind of wraps around. Right here, you'll see as exhaust gas comes out and it heats up this little unit right here. The engine coolant wraps around this passage right here in the exhaust. So comes through here, loops around, and it heats us up to superficial. This really high surface contact area all the way around this recirculated heating unit in the exhaust system. Like I said, in some vehicles actually have it go around the catalytic converter. It depends what you're working on. Just pay attention. If you see coolant hoses going to the exhaust system, that's what it is. So I don't know if you're familiar with an airlift, or also known as a rad kit, but if you're going to remove any of these parts, there's lots of valves, lots of motors, actuators, all this stuff in that system that can possibly create these air pockets that are hard to purge or drain. So if you have this system, basically there'll be a video link on how the system works here on Canvas, but this system pulls the whole coolant system into a vacuum, which is going to remove that oxygen, much like you evacuate. It's similar, not the same, but it's similar to how you evacuate an AC system. When you recover that refrigerant, then you have to go to evacuate it to remove all of that air and refrigerant out of the system. Very similar. So it's going to pull the whole system. You'll see the coolant hoses suck down, but basically you hook up the system, hook it up to shop air. It sucks the system into a vacuum or less than atmospheric pressure. You operate with a scan tool, electric motors, valves, blender, mode doors, anything that like that coolant control valve, anything that has coolant going through that, so you can get that air pocket out. Any bleeder valves, you want to try and get all of that air system out of it. Follow the OE manual on what to operate. Again, I wouldn't use it to open up a bleeder while this system's on because you're sucking air into the system. But basically, there's a sequence you're going to want to follow, and it's in the service procedure about how to get air out of the system. Me personally, I hook up the scan tool while this system's on a vacuum. I use the airlift or rad kit, which is a similar system by Snap-on, to pull the system onto a vacuum. I can see the radiator hoses sink down. I'm going to make sure it's holding the vacuum. I'm going to operate coolant control valves. I'm going to operate electric water pumps, anything that I need to try and get the air pocket out of the system. Let it sit there for a minute or so, and then I'm going to refill it with the correct 50-50 mix OE coolant. And this system does that for you. Again, check out the video. When you're ready to refill it, you turn the valve or move a hose, depends on the system, and it'll replace that vacuum in that cooling system with 50-50 mix coolant that you mix in a bucket prior to. Again, never add a little coolant, little water, little coolant, little water. That's not a proper way to mix. You want to mix it in the bucket and then add it. Mix it with the concentrate OE coolant and distilled water. Never use tap water. Tap water has minerals and other items in it, impurities that can damage your cooling system or cause corrosion. So some vehicles have these air valves I was mentioning. If you are just filling up normally without the system under vacuum, you can open up these air valves, air release valves. and this will allow you to purge the system, and it makes it easier to drain the coolant from the system, because if you open up this radiator drain cock plug's drain valve and there's no way atmosphere can get into this cooling system, it's going to create kind of a vacuum hold. It won't drain the coolant. When you open up these release valves, it's going to allow all that coolant to come down, because as the coolant comes out, it needs to be replaced with something. If there's no air allowed in the system, it's just going to hold the coolant up here. It won't drain because there's no air to replace it. So these air valves are necessary to drain the coolant and refill it. You open them up, as you fill coolant, it's going to push the air out. So 2 reasons I use the air release. Here's a couple different Priuses, a Gen 1 and a Gen 2, showing you where some of the bleed valves are. Here's a bleed valve, here's a cap. This one's kind of sucked down into, there's actually one right here. That's a bleed valve, it doesn't show you on the screen, but there's a one right here on this Gen 2, right inside that core support, radiator core support. There's a hole there that goes down to a bleed valve. Here's a coolant fill for the engine. This is the coolant fill for the MEX, motor electronic cooling system. So again, to drain the coolant, I already mentioned it, but open bleeders. Run scan tool helps purge that system of all that coolant. And don't forget, on this Gen 2, it has that coolant thermos bottle. It's basically under the driver's fender right over here that you're going to have to access and drain as well. And remember, it's hot. So another diagnostic tip, just like how we used an infrared gun to see if the catalytic converter is working, although this isn't a bar approved diagnosis, it's just more of a heads up for a tech. We're looking to see about 100-degree temp increase. We can determine the health of a radiator, looking for even temperature decrease across or down a radiator, depending on the type of radiator, and when a thermostat opens, using that same infrared gun. In fact, infrared gun is one of my favorite tools as a technician. I utilize this a lot because I worked on old vehicles that were prior to scan data, and I got used to information. As a modern tech, you're used to data and information. When you work on an old car, it's more of a feeling. It's kind of it's almost artistic. It's hard to explain. But the infrared gun allowed me to diagnose old cars with data. I can actually look for cylinder misfires using an infrared gun, because the cylinder that's misfiring is going to be cooler than the nearby cylinder. So that would help me diagnose that. Modern vehicles and old alike, you can use the infrared gun to diagnose thermostats opening, check it for hot spots in the engine. You can check radiators. In fact, I think that's what these are right here. You can check brakes, make sure that the brakes are even. They're not dragging. Like, let's say the customer says it's pulling off to the right or dragging off the right. You can tell if it's a brake drag. You can see if they're cooling or stopping adequately on the brakes with an infrared gun, just checking that rotor. Again, you're going to want to check them left to right, not front to rear, because front to rear, they will be different. You're just checking left to right to be pretty close. Again, checking for catalytic converter working, radiator, engine misfires. That infrared gun is by far a tool you're going to want to get. So moving on to the hybrid system. In the cabin, there's some duct work and mode doors that you're familiar with, but we'll recap it real quick as per the hybrid vehicle. So conditioned air enters the plenum either from fresh air or recirculated air and is directed through the evaporator and either through or around the heater core. So we send it through the evaporator first because that's going to condition the air and dehumidify it. And then depending on if you want hot air or not, it goes either through the heater core or around the heater core. And some vehicles, if it goes around the heater or goes through the heater core but you don't want hot air, there's a water valve that shuts off coolant to the heater core. Okay, so it depends on the system that you're working on. After its desired temperature, then it goes through what's called mode doors to its final destination. That's basically, windshield defroster outlets, dash outlets, side window floors, dash, etc. So here is a heater core. Basically, this looks like an F-150. So here it comes out here to the heater, to the firewall, and out right here. A couple things to think about when you're diagnosing these. Again, is think about the system. Does it shut off coolant flow to heater core on the system or not? Because that can be part of the diagnosis. Me as a tech, I like to figure out if it's in front of the firewall or behind the firewall when I have heater problems. What I mean by that is, do I have hot coolant getting to the heater core? That's in front of the firewall. Is the engine working? Do I have hot coolant? It's not blocked? That shutoff valve isn't working or is on accidentally or malfunctioning? Do I have low coolant? All of that is in front of the firewall. Or it could be something behind the firewall. Is the heater core plugged? Is a motor temperature blend door not working? Is it a control mechanism? So I try to figure out if I have a complaint, is it in front of the firewall or behind the firewall? So, but as far as hybrids go, a little bit different because of idle stop. And we have higher efficient ICEs, so they don't create as much heat due to that Atkinson cycle. So we need supplemental heating devices, one of which is a PTC, positive temperature coefficient heater. It's basically a resistive heater right here. It goes in between these fins every so often. There's one, they'll have like another one off and on. It's basically, again, a resistive heater, just like a defroster grid in the back of your window. It's going to just run current through it and create heat, and then the fan blows through this, and so it's kind of a supplement heater, and that's driven off of either the high voltage system or sometimes, actually I can't think of one where it's low voltage, just high voltage on the cars that I know of. So be aware of that. Yeah, there it is right there. Actually, yeah, this one. These ones were low 12 volt systems. These weren't high voltage batteries. So I regress. I could be wrong. See? Don't trust me. All right, moving on. We can also have a PTC in the ducting right here, built into the ducting instead of the heater core. So it goes down to the feet, the footwell, etc. They're basically resistive heaters again. So here's a high voltage one that's off of EV Focus. This cable is actually orange in the vehicle, and it goes down, this high voltage cable goes down into that resistive heater. Coolant comes in, heats up, and then goes through to the heater core. So this kind of is what heats that coolant to heat the cabin. Very inefficient, uses a lot of electricity, so not a great option. Here's that orange cable, an actual picture of it. Again, right here before it goes to the heater core, it goes through that positive temperature coefficient, which means I send current through that. As heat goes up, resistance goes up, so it's self-limiting. It's basically a short to ground that's going to self-limit its own current based on heat, and then that heat goes into the coolant, and the coolant goes to the heater core, fan blows in the heater core, and you're toasty and warm. But you're burning energy and lowering your range. So what manufacturers also do is utilize a reverse heat pump kind of system, where they use the AC, air conditioning circuit, to heat the cabin. It's kind of a reverse system. So think about the condenser and the evaporator, right? The evaporator is where it absorbs the heat, so that keeps it cold in the cabin, right? And then we dump that heat into the atmosphere through the condenser. Well, in this cabin heating system, this heat pump system, it's going to reverse that. The evaporator is outside, and then the condenser is going to be in the cabin. So the hot air is there's heat being removed out of the atmosphere and dumped into the cabin. And you're thinking, well, how is there heat in the atmosphere if it's 40 degrees out and I'm cold? I want hot air. Believe it or not, there's still quite a bit of heat in 40 degree ambient temperature. So the system will capture that heat, and then it pumps it into the condenser to be dumped into the cabin. So it works just like your normal AC refrigerant system, and diagnosed accordingly. A little more complicated, as you can see in this picture, but it actually is much more efficient than using that positive temperature coefficient. Many vehicles use this. I know for sure that the Nissan does, but I assume that many other vehicles do as well. So electronic cooling, you have your MEC system, motor electronic cooling system. If you notice, the inverter and the overflow and this water pump and the transaxle all comes through this bottom portion of this radiator. The top portion goes to the ICE. So it's one unit that's going to have two different cooling systems in it. But luckily they use the same coolant. You can also have, here's a filter right here, here's your overflow, etc. So could be different systems in one radiator. They'll have different valves, but they all operate this little pump. And again, it doesn't have to be a hybrid to have this electric motor. I've seen these on many non-hybrids. European cars particularly use electric water pump like this. But Escape hybrids I saw was the first hybrid I saw that had these. But many hybrids have many electric pumps, 3 or 4 of them. And many models. So it's cycled on and off at different speeds to accommodate coolant temperature and movement. So here's another style system. Before we had the 2 completely separate systems sharing a radiator. This system, like on a Ford, it's going to have coolant pumps and coolant valves, where it has one degas bottle, and then that goes into 3 different kind of sections or loops of the cooling system. So the valves will have the different loops with different temperature sensors to keep them at different temperatures, and they have different motors, and they all share the same coolant in the same degas bottle. But because different items require different cooling temperatures, they may cycle different times. This concludes part 2. I remember this time. I'll see you at part 3.